An anonymous function is basically a baby function. An anonymous function is a function that is not stored in a program file or MATLAB file. I mean a file that ends with an .m extension, but it is associated with a variable. And the data type of that variable is a function handle. Anonymous functions can accept inputs and return outputs, just like a regular function. However, they can contain only a single executable statement. So here I've defined an anonymous function that squares a number. In order to define an anonymous function, after the ampersand here, you list the input arguments inside parentheses. So there is only one input argument here, but there can be more than one input arguments. The input arguments are followed by an expression that gets evaluated each time we call the anonymous function. Now the function handle here is stored in a variable called sqr. When we need to call the anonymous function, we can just pass argument to this variable to call this anonymous function and execute the expression written herein. So if we just execute this, we have the square of 8 is 64. So the square bracket 8 basically invokes this anonymous function with this input argument 8, and the statement is executed. Now many MATLAB functions accept function handles as inputs so that they can evaluate functions over a range of values. These handles might come from anonymous functions or regular functions. The benefit of using an anonymous function is that you don't have to edit and maintain a file for a function that requires only a brief one-line description. One example will be the integral function of MATLAB, which integrates the expression sent as the first argument. So the integrand is the first argument here, with the second argument as the lower limit of integration, and the third argument as the upper limit or higher limit of integration. Now if we execute this, we see that we get the output of integral 0 to 1 x squared dx. This is 1/3. Now instead of using a variable to store an anonymous function, what we can do is that we can just cut out the middleman and create a temporary function handle as shown here. So here I directly input the anonymous function to the integral variable instead of the function handle. And if we execute this, we see that we get the exact same output without using a variable as function handle. So the bottom line is that we can use a variable to store an anonymous function, the function handle of the anonymous function, but we can also directly pass the anonymous function as arguments to a MATLAB function that takes function handles as inputs. But in my opinion, it's always better to have the anonymous function stored in a variable, because the point of having an anonymous function that you don't have to write this expression again and again. So if you have to write this anonymous function again and again, that defeats the purpose of having an anonymous function in the first place. So the point of having this is to replace it with a small variable name, so that we can each time when we call the function with this variable, this expression, which can be arbitrarily large, is executed. So it's always better to store the function handle of the anonymous function to a variable and then use that variable to call that anonymous function. Now, function handles can store not only an expression but also variables that the expression requires for evaluating that expression. For instance, I created a function handle here of the equation of a parabola ax squared plus bx plus c. which requires the coefficients a, b, and c, and I've set some values of a, b, and c here. So if we just invoke, so we've stored the function handle of this anonymous function to this variable parabola, and if we invoke this parabola variable with, or function handle rather, with an argument, this expression gets evaluated and we get this output. Now what we're going to do is that we're going to delete these three variables a, b, and c from the workspace and see if there's an error message. There you go, no error message. See, I've cleared this variable a, b, and c here, but parabola 1 is still working. So how's that possible? So yes, when we're deleting the variables from the workspace, a, b, c indeed gets cleared, but the function handle here basically stores all the variables that are required to evaluate this expression. So in order to evaluate this expression, one needs the values of a, b, and c. That's why the function handle basically stores the values of a, b, c that I said earlier. So because a, b, c are variables that we created at the time of creating the function handle includes those variables, and the values persist within the function handle even if we clear the variables. So how then do we change the variables if we need to? To supply a different value of the coefficient, we must create a new function handle. So I've defined basically the parabola anonymous function again with the different set of a, b, c values here. Now if we execute this part, we see that this time the value is different, which means the ABC value was indeed changed this time. So if we want to supply a different value for the coefficients or the variables that are required to evaluate the expression in the anonymous function, you must create a new function handle and call that using a variable. We can also save function handles and their associated values in a mat file and load them in a subsequent MATLAB session when we need them using the save function. So this is the mat file, this is the name of the mat file that contains the function handle, and this is the name of the function handle. So if you want to store this mat file in a specific folder or directory, you just type the full path like c users user documents myfile.mat, something like that. But if you don't write anything, it is stored in the your MATLAB directory basically. So this is my MATLAB directory and this is the mat file it's storing. Using the load function, you can at a later time or in a later script load this mat file and retrieve this function handle parabola, which contains the values of a, b, c and this anonymous function with this expression. Okay, so can we have like multiple anonymous functions or like nested anonymous functions? So it is possible for an anonymous function to have another anonymous function inside it. So let's say we're trying to implement this equation in MATLAB. So we're integrating this x squared plus cx plus 1 from 0 to 1. So how do we implement that using anonymous function? So here we use the integral function. The first parameter of this integral function is the expression here, and that's the lower limit and that's the upper limit, 0 and 1 respectively. Now this integral function is actually a part of another anonymous function, which basically controls the c variable here that is required to evaluate this integration as well. So we have an anonymous function here, and inside it we have another anonymous function that is used by the integral function of MATLAB. So let's just execute this part. So when we want to call it, we assign the function handle to the variable g here, so we can use this to invoke the anonymous function, just like ordinary anonymous functions. Anonymous functions might also have no input arguments. So if our function does not require any inputs, we used empty parenthesis, just like we did here, to define the call of the anonymous function. So dateStr function basically converts the time to like a date time format that we are more used to, because now is basically the present time, but it's basically a double number. So this number is basically represents the number of seconds that have passed from a reference time. So the dateString function basically converts this second into a time format that we understand. So the t function here, the function handle t here, basically contains this anonymous function which does not have any input. And if we want to call this function, we just type t followed by parenthesis, empty parenthesis, without any argument or anything. So if we execute this section, we see that we have today's date and the current time here. Now, omitting this parenthesis here, this parenthesis is critical. Omitting this parenthesis here in the assignment statement creates another function handle. So d here, we see d here is a corrector type variable. D here is a corrector type variable. But if we sort of omit the parenthesis here, what happens? Let's check out what happens. Now the variable d is basically a function handle. So d is not a corrector array anymore, it's a function handle. So the parenthesis here makes all the difference. So if we want to assign the return value of the anonymous function to a variable, we type the parenthesis here, which invokes the anonymous function and executes it. But if we just assign the function handle t to another function handle, we omit the parenthesis, and there you go, you have your function handle. So on top here, d is a corrector type variable or corrector array, and at the bottom here, d is a function handle. So it depends on what you want to do with it. It is also possible to create arrays of anonymous functions, where let's say you have multiple expressions that you need over and over again in your script. So you can sort of pile them all up in one array. So here I have piled up 3 anonymous functions here, 1, 2, and 3, x squared y plus 10 and x squared plus y plus 10 in one array. So the way you call it is that so this is basically a cell array. So the first element of the cell is f curly braces 1, and then it is followed by the input arguments of that anonymous function. So if we execute this section, it becomes clear. It will become more clear. So here, the f19 means the first element of the cell here gets an input argument of 9. So 9 squared is basically 81, which is why we're getting 81 here. Again, f curly braces 2 parenthesis 10 means the second anonymous function, or the second element of the cell array, gets an input argument of 10, and 10 plus 10 is 20, which is why we get 20 here, and so on. So we can also create arrays of anonymous function and call them by passing arguments. So that concludes our tutorial on anonymous function. Thank you.